In just a few weeks, an open-source project called OpenClaw became the most rapidly adopted software in history. It achieved a level of global developer interest that usually takes decades to cultivate. For context, look at Linux. Since its release in 1991, Linux has become the backbone of modern servers and the internet. OpenClaw exceeded the 30-year adoption curve of Linux in less than a month. This follows a historical pattern of computing leaps. Windows defined the personal computer, HTML enabled the global internet, and Kubernetes powered the mobile cloud. OpenClaw serves as the operating system for a new category of technology, the agentic computer. This is a system designed to execute complex, multi-step workflows autonomously rather than just responding to individual user commands. This transition changes the nature of software. Instead of users operating tools, the software itself acts as a digital worker, performing tasks independently to achieve a specific outcome. The practical utility of these agents was proven almost immediately. One user's 60-year-old father used OpenClaw to automate an entire lobster selling business, connecting hardware via Bluetooth, building a complete e-commerce site, and managing hundreds of orders overnight. OpenClaw functions by breaking a single prompt into a sequence. It manages resource access, acts as a file system, and spawns subagents to execute code without human supervision. However, this level of autonomy creates a significant security barrier. Deploying an unmanaged agent within a corporate network introduces risks that most organizations cannot accept. An untethered agent has the native ability to access sensitive employee records, read proprietary financial data, and execute its own code. Because these systems have external I/O capabilities, they can also transmit that private information via email or text message. For a major corporation, the operational risks of a data breach outweigh the productivity gains. Until the security gaps are closed, the software remains incompatible with the requirements of the modern enterprise. NVIDIA addressed this by collaborating with Peter Steinberger to develop Nemoclaw. This is a reference design, a blueprint for a secure software stack designed to contain and govern these autonomous agents. Nemoclaw functions as a structural vault. It places the high-performance OpenClaw engine inside a controlled environment, ensuring that every action the agent takes is visible and restricted. The primary defense layer is OpenShell. This technology integrates with a company's existing policy engine, acting as a filter that blocks the agent from making unauthorized external connections or accessing restricted files. It also includes a privacy router and specialized guardrails. These components ensure that sensitive corporate data never leaves the internal perimeter, even when the agent is communicating with a large language model. By adding these governance layers, Nemoclaw allows large organizations to deploy autonomous agents while maintaining strict compliance with security and privacy standards. A secure environment is only useful if it contains capable intelligence. To be effective, these enterprise vaults must be populated by specialized digital workers. NVIDIA provides this through an ecosystem of nearly 3 million open models. The Nitron family forms the core of this group, offering frontier-level performance in language processing and complex reasoning. The ecosystem includes specialized domain models like Earth-2, which uses AI physics to generate high-resolution weather and climate forecasts. This level of specialization allows agents to perform tasks that standard language models cannot handle. Companies can fine-tune these base models on their own proprietary data. This process turns a general-purpose AI into a specialized expert that understands the specific nuances of a company's internal operations. IT procurement now focuses on fine-tuning these base models into specialized domain experts that operate as digital employees. For decades, the IT industry focused on providing tools, databases to store information, and applications for humans to use. This model is being replaced. Software as a service is shifting toward agentic as a service, where companies provide autonomous workers that perform the labor themselves. This shift is already changing how high-level engineers negotiate their compensation in Silicon Valley. A competitive salary is no longer the only priority. Modern contracts often include a significant annual AI token budget. A token is a basic unit of text or data processed by an AI. In this context, it represents a direct allocation of computing power. An engineer with a massive token budget can use AI agents to automate testing, debugging, and deployment, allowing a single person to manage the workload of an entire traditional team. We have moved from the raw, unmanaged potential of OpenClaw to a structured, secure architecture in Nemoclaw that is ready for the corporate world. The Nitron coalition, which includes companies like Mistral, Perplexity, and LangChain, is now working to standardize this agentic foundation across the entire tech industry. Just as the 1990s required every business to have an internet strategy, the current environment requires a comprehensive OpenClaw enterprise strategy. The transition from selling tools to renting specialized agentic intelligence is turning enterprise IT into a multi-trillion-dollar market.